Hey, what did the acorn say when it grew up?
I'm a tree now.
G, I'm a tree.
I don't get it.
What did the acorn say when it grew up?
Don't say it again.
G, I'm a tree.
I don't get it.
What's this class? Geometry.
It's
So funny. Thank you, I got it from the slides. Okay?
Yeah, no figures.
Yes.
Last year, my mom wanted to do a Halloween costume where she dressed up as a tree and I dressed up as shapes and I said no.
I'm a tree.
That'd be funny. Okay. Hey, my name is Mr. Kossel.
That's not me.
Oh,
Right.
No,
Mr. Kossel, we didn't do the last name.
I know.
Yes, we did.
It's always weird to me that, like, if you see the future in public, what are you supposed to call them?
I used to call all my old high school teachers and coaches Coach and Mr.
Oh my goodness, you've got our warm-up problem all here.
Imagine like going up to like Mr. Howard. What's his name? Like Thomas, right?
Yeah.
Hi, Thomas.
His name's Mr. Okay? Deductive reasoning. Deductive reasoning is the process
Mr. Costa.
Good morning.
of reasoning. No.
David, go.
Logically.
Good morning, Cheyenne. I'm gonna go up to Mr. McCoy.
No, stop that.
Don't.
Okay?
Don't.
And drawing, he will not take kindly to that.
No.
Drawing, Mr. Howard would take more kindly to that than Mr. McLean. Okay?
I'm not saying
Then drawing a conclusion.
To be fair, Mr. Howard teaches his students.
Okay, wait, does every freshman have Mr. Howard then?
No.
Most.
Dang. You guys
Most.
should have it.
I know.
No, because there's some
Hey, judge mode. Judge mode. The process of reasoning logically and drawing a conclusion from given facts and statements is called deductive reasoning.
You said it. You're okay.
Oh, oof.
Dude, your writing is like doing so well today.
No, it's not.
That's the joke!
I thought she was like miles away.
You got tired of me judging him so bad.
It's true.
I'm in the back.
Mike.
It's so quiet. Like, it's just like
That's why I randomly did that.
Huh? I cannot hear you.
Did you say it was so quiet?
Law of detachment. Given in a conditional statement, if the hypothesis is true, if our hypothesis is true, then the conclusion is true. So we're saying if we're given a conditional statement, if the hypothesis is true, then we automatically know the conclusion is true through our law of detachment. Through our law of detachment. Okay? We're going to talk about that and why, okay? So in a symbolic map, this might not make sense to you, okay? Well, I'll try and explain it. Okay? This is our don't take up the whole box, take up the top little part like I did. Okay? That's a conditional statement, right? Conditional statement, if P then Q. Given a conditional statement, we're saying if P is true, we then draw this. These three dots are just symbolic for therefore. Those three dots mean therefore. So we put a line and say therefore. We don't want to write out therefore. So if P then Q, and P is true, therefore Q is true. So in our if then statement, if our hypothesis is true, we therefore know that the conclusion is true. That's just what it looks like in symbols.
Is it true if the hypothesis?
Why do we need therefore? That is the most pointless
What is therefore therefore?
waste of
Okay, what? Therefore.
Stop
No.
here.
Okay,
Thus. Because of. So, yes.
if the conclusion, or I mean, if the hypothesis is false, does that make it
We'll talk about that.
Cold her.
So that means it's not.
We'll talk about it.
Wait, what? Wait. I don't like this
Today
one.
we're going to dive more deeply into deductive reasoning, which is also called logical reasoning. We're going to look at some given conditional statements to make facts or conclusion. We're specifically going to look at the law of detachment and the law of syllogism. We're going to start with the law of detachment. It says that we need to identify the hypothesis. If another statement has the same hypothesis, then you can make a conclusion. let's look at a given statement because then this will make a lot more sense. Let's say that we're given the statement, if there is lightning, then it is not safe to be outside.
That's a conditional statement, right? If there is lightning, then it is not safe to be outside. What's the hypothesis there? There is lightning. What's the conclusion?
Not safe to be outside.
Okay, is that true?
Yes.
Okay, if there's lightning, it's not safe to be outside, okay?
Oh, yes it is.
Continuing on.
Then we're told that Preston is outside playing baseball, and then he looks up and he sees some thunder and lightning. Well, we could say Preston sees lightning from the baseball field. And see, it's not an exact match to our original conditional statement, but it's the same idea. The hypotheses are the same. If there's lightning, Preston sees lightning. Well, then we can make the same conclusion. It is not safe for Preston to be outside.
So that's just an example of what the law of detachment there states, okay, saying that, hey, they have the conditional, the hypothesis is true. Preston sees lightning, so that means there's lightning. That means the hypothesis is true. So that means we can draw that it is not safe for him to be outside. We can say the conclusion is true, okay? That's what the law of detachment is saying. It's going to go into a couple examples.
Preston to
as
be
others.
outside. Now, let's take a look at the same conditional statement. If there is lightning, then it is not safe to be outside. But this time, we're going to do a restatement of the conclusion rather than the hypothesis. It's not safe for Preston to be outside.
Okay, so here we have our same thing, but now we're told the conclusion is true. What do we think that might tell us? Does that tell us anything about our hypothesis? What do we think? Okay, if it's not safe for him to be outside, does that mean there's automatically lightning? No, so is the hypothesis necessarily true?
Not yet.
No, it could be, but we don't know, do we? Because what else? Could there be something else out there that's not making it unsafe? Okay, it could be a bear. Okay.
Well, you know what? There could be a lot of reasons why it's not safe for Preston to be outside. Well, what if there are lions roaming around? Definitely not safe to be outside. Or what if there's a big, huge windstorm? Whoa, definitely not safe. Well, what if there are little green alien men running around all over the place? Definitely not safe to be outside. Well, again, there could be a million reasons why it's not safe to be outside. We just cannot make a conclusion.
Okay, so you can't make a conclusion. If you're just given the conclusion is true, you can't make a conclusion. You can't make a conclusion about the hypothesis. Okay, you can't draw anything from that. We don't know if the hypothesis is true or false. So we're left to no man's land. Okay.
When there's a restatement of the conclusion. So to summarize, the law of detachment says that we need to identify the hypothesis. If another statement has the same hypothesis, we can make a conclusion. Putting it into our symbolic notation, if P, then Q is true, and P is true, and again, P is just a restatement of the hypothesis. It doesn't have to be word for word verbatim. Well, then Q is true.
They use the word then instead of there's one.
Okay, same idea. Okay, hopefully that gives us a little bit deeper understanding. Hopefully it's a more visual way, a little fun, silly, goofy way as well, okay? You know I love fun, silly, goofy, okay? Lights going on. Okay, so continuing on, example 1. We're going to use the law of detachment to give a valid conclusion. If we can't give a valid conclusion, then we're going to write no valid conclusion. Seems reasonable, okay? If Mark saves $30, then he can buy a new video game, okay? What's our hypothesis? Okay? What's our conclusion? Okay? What are we told? So are we told the hypothesis is true? So what do we automatically know? The conclusion is true that he can buy a new video game. So I actually put a W there instead of a V. It reminds me of this time. I had a friend who was a foreign exchange student from Norway when I was a junior in high school. He was also a junior. He and I hung out a lot. His name was Nikolai. He was pretty awesome. And so there are parts of of English that were like a language barrier for what he was used to, okay? He was actually very good at English, though. He was more skilled at English than a lot of people here, unfortunately. But he's like really good, okay? And so, but there were just some things that just didn't quite overlap super well. And so, like, one time, he was playing Halo with another one of my friends, and he's like, there was some cars there. If you know anything about Halo, there's like warthogs, stuff like that, some things you can drive, okay? I'm avoiding a specific word on purpose, okay? And he's like, and like one of the friends like calls it by name, like, oh, it's a warthog. And he's like, is that one of the vehicles? And he's like, a what? A vehicle. A vehicle? Because apparently a lot of times in like other languages he knows, like he also like knows like some like German and stuff like that. In some of the other languages, the V is often pronounced like a W. So he just like assumed that's how it was. So it's just like a vehicle. So I actually put like video, and so that's what that made me think of. Anyway, if a quadrilateral is a rhombus, then it is also a parallelogram. So ignoring that part so far, if a quadrilateral is a rhombus, then it is also a parallelogram. What's our hypothesis here? Okay. What's our conclusion? Okay. And then what are we told after our conditional statement? Okay, we're told that this quadrilateral is a rhombus. So what are we told is true? Okay, so we automatically know that it's a parallelogram. Because we were given that the hypothesis was true, we know the conclusion is true. So we know that it, or quadrilateral apsidy, okay, is also a parallelogram.
If you were to do one other kind of mathy job, what would it be?
I don't know. See, I tried my hand at accounting for a while. Like I took some accounting classes in high school, and they just weren't my jam. I don't know.
What's a parallelogram?
A quadrilateral with two pairs of parallel sides. The opposite sides are parallel. If you are 18 years old, then you can register to vote. Okay, what's our hypothesis? Okay, what's our conclusion?
You can vote.
You can register to vote. What are we given?
Olivia is not 18 years old.
So Olivia cannot vote.
So we're told not P. Do we know if we can draw a conclusion from not P?
No.
Were we told we could?
No.
No. So what do we think?
She can't draw a conclusion.
No valid conclusion. Let me explain why. You might say Olivia can't register to vote. Okay? No valid conclusion. Well, hey guys, I am 23 years old. I'm 23 years old. I'm not 18, but can I register to vote?
Yes.
Yeah. So we can't assume that because she's not 18, that means she's younger. Okay? You can't assume that. Okay? But so we're just told not P. So we can't know anything. It's possible that she can register to vote. It's possible she can't. We don't know. So we can't draw a conclusion for sure. Okay? Melissa.
They would have added yet to it, could we draw a conclusion?
Is not 18 years old yet. Then we could we could draw a conclusion through this law, but we could draw a conclusion through our other logic. So this law very specifically states we can only draw a conclusion when the hypothesis is true. So using the law of detachment only says when the hypothesis is true. So if we are given not 18 years old yet, we would know she can't register to vote, but we don't know that based on this law. We know that just because of our laws about voting. Does that make sense? It's weird. Okay? But for our purposes, whenever you're given anything other than P, then we know valid conclusion. 4. If the sum of the measures of two angles is 90 degrees, then they are complementary. What's the hypothesis?
Sum of the measures of two angles is 90 degrees.
Very good. What's our conclusion?
They're complementary.
Yeah, and then what are we told after that?
And the measure of angle J equals 58 degrees, and the measure of angle K equals 32 degrees.
So what's this? What would those add up to be?
90 degrees.
So we're told that what is true.
That is true.
So what can we draw from that?
They're complementary.
So we can say that these two angles are complementary. So we can say angle J and angle K are complementary. So we have to do some math there, but we are told that they add up to 90 degrees. Means if we add them up, oh, we get 90 degrees. Okay. Number 5. I want you guys to try it. I want you guys to try number 5.
Really?
Yes.
Right when it flip flops on me?
Yes.
That's rude.
Yes. agreeing with you. I don't know why you're upset. Okay, what's our hypothesis? Okay, you plan to that problem. Okay. Taylor, what's our conclusion? Okay. Justin, what are we given?
Sarah purchases a prom ticket.
Okay, and what is that? Would that be P or Q?
That'd be P.
Q. Purchases a prom ticket, purchases a prom ticket. So can we draw a conclusion that she's going to attend prom? No. Maybe she just really wanted to buy a ticket. Maybe she bought a ticket for a friend. Okay?
P makes Q true. If Q is true, then P should be true.
Well, the baseball field explanation. There's lightning, so it's not safe. It's not safe. That doesn't mean there's lightning. It's a possibility, but it doesn't mean it. Sarah bought a ticket. Okay, well, we don't know if she's paying to attend prom. Maybe she bought it for a friend. It's possible. Some people are good friends, Grady.
Yeah, well, good friends go to prom together.
Not necessarily. Okay, continuing on. Okay. Law of syllogism. Law of syllogism. Okay. This allows you to draw a conclusion from two conditional statements in which the conclusion of the first, the ending of the first statement, is the same as the hypothesis of the second statement.
You totally just implied I have no good friends. That was really rude.
Yes.
That was really rude.
And then also that you're not a good friend.
You haven't gotten-
Don't forget, Greg, don't forget the second implication, that you are also not a good friend. Not only do you not have
The
good
second
friends,
one's
you're
true.
not one.
But Graydon has his moments.
Yeah, okay.
Not very often.
In symbol math, we're saying we have a conditional P to Q. If P, then Q. We have conditional if P, then Q. And then we're saying the conclusion of the first will be the same as the hypothesis of the second. So in our second one, our conclusion, our hypothesis will be Q, because we ended with Q in our first. And so now we're going to go Q to some other statement, so we can go to R, because we talked about R being statements before as well. Therefore, there's our therefore again. Therefore, we can go straight from P to R, cutting out the middleman Q. You can go straight from P to R, cutting out the middleman Q. Oh, but if only we had a video we could watch.
Oh, God.
Oh.
Make more sense.
This makes plenty of sense. We can skip the video.
Where did you get R from?
I came up with a third statement. I could have called it R. I could have called it S. We just talked about R being a third statement before.
Why not use the ABC?
Okay. Because I don't want to. Okay. I can explain it later, Dale.
Well, now let's look at the law of syllogism. And it says you can make a conclusion if the hypothesis and conclusion from two conditional statements are the same. Let's look at an example, make a lot more sense. Let's say we're given a statement. If everyone does their geometry homework, then they will pass geometry. If everyone passes geometry, then Mrs. Gray will have a party.
Notice it does not say Mr. Costa. Okay. Anyway, so this first one, it goes P, then Q. P is everyone does their geometry. Everyone will pass geometry. Everyone does their homework. Everyone will pass geometry. P, then Q. This one goes, everyone passes geometry. That's the Q from before. And then here, Mrs. Gray will have a party, not Mr. Costa. Okay. This is our R. That's the third statement. Continuing on.
Well, we can conclude then that if everyone does their geometry homework, well then, voila, Mrs. Gray is going to have a party with lots and lots of cake. Well, let's look again at our original statements. There is a match. We have a hypothesis that then we will pass geometry, and another match if everyone passes geometry. Well, we basically just crossed those out and combined our hypothesis that we started with and our conclusion that we ended with. We just crossed out the matches and combined what's left over.
So now, if everyone does their geometry homework, that was our P originally. And Mrs. Gray will have a proper party. That's R. So now it goes. Now it goes P to R.
If everyone does their geometry homework, then Mrs. Gray will have a party. So to summarize, the law of syllogism says you can make a conclusion if a hypothesis and conclusion from two conditional statements are the same. And that's again where we saw that match. In putting it into our symbolic notation, if P then Q, if Q then R, well then we can conclude then, if P then R. Again.
Nope. Okay. So, what's going on here? We're going to use the law of syllogism to give a valid conclusion. If we can't, then we're going to write no valid conclusion again, okay? So, if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. Okay, first conditional statement. It is Saturday. What are we going to call that? P. Awesome. Then Jake has a baseball tournament. What are we calling that?
Q.
Okay, it's something new. It's Q. Okay, second conditional. Jake has a baseball tournament. What are we going to call that? Q. We've seen it before. He will need to pack his lunch. R, because that's new. So we go, if P then Q, if Q then R, so what can we do? We can go if P then R, okay? So we can say, if it is Saturday, then Jake, we should probably say who he is at that point, then Jake will need to pack his lunch.
But isn't like the fact that he has a baseball tournament like an important fact? Tournament.
Yep. But because it's in both those conditional statements, we can assume, oh, now this is saying if it's Saturday, Jake has a baseball tournament. So that's saying every single Saturday he has a tournament. Well, every single time he has a tournament, he needs lunch. So every single Saturday, he needs his lunch.
Yeah. What if someone who goes and read the top part and just reads the bottom? If it's Saturday.
Well, that's your own.
Sarah,
Could you put it is Saturday, therefore Jake will need to pack a lunch?
we're going to keep going with our if-then statements
Okay.
because we like to keep things in our
Then
if-then.
why
We
do you
like to
have
keep
it therefore in your symbolic math?
Ooh, because therefore, if it is Saturday.
If it's Saturday.
Okay.
That is.
If it's Saturday.
If a number is divisible by 2, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3.
12.
A number is divisible by 12. What is that?
C.
It is divisible by 6. What is that?
Q.
A number is divisible by 6.
Q.
Okay? Is that word for word the same?
Yeah. No.
No, but is it really the same thing?
Very much.
Yeah, because a number. Well, what is it representing anyway? A number. So it's really the same thing. If you don't like that, go back to English. It is divisible by 3. That would be our R. Okay, so Rachel.
So are we just assuming that all this is going to be correct all the time?
Yes.
So we don't have a truth.
We're not worried about truth values. So when we do these laws, when we do law of detachment, law of syllogism, okay, or when we're doing law of syllogism, we're not worried about truth value. When we're doing law of syllogism, we're not worried about truth value, okay? But all of this is true, okay? So then what's our conclusion we can draw?
If a number is divisible by 12, then it is divisible by 3.
Very good. We can cross out our Q and we can go, if a number is divisible by 12, then it is divisible by 3.
What if I wrote the like the division?
I suppose. Okay. Questions on that one? Okay, you guys want to do number 8?
Yeah.
Yeah, we're not going to.
Go ahead.
What? Okay. Anyone still need 6 and 7?
Can we have homework?
Shut up.
Is this the rest of this?
Finish.
Just do homework.
Let's do number 9. If it is sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear shorts. What's our first sentence? It is sunny this weekend. What is that?
Hey.
Oh, this is dumb.
You will go boating. What is that?
Q.
It is sunny this weekend. What's that?
P.
P. We saw it earlier. You will wear shorts. What is that?
R.
Okay, so here we go. P to Q, and here we go P to R. Was that what our law of syllogism said?
No.
So can we draw a conclusion?
No.
No!
Did
You
you
can't.
say that this was going to be the truth the whole time?
I said we're not going for truth values, we're going for the pattern.
This is.
We're
D
seeing the
and
pattern here. If it goes P then Q, Q then R,
E and
then we can use the law of syllogism.
M.
But
M.
Is this conclusion the same as this hypothesis? No, so we can't draw anything from it. Okay, these have to be these two corners have to be the same. Melissa. Nope, we can't say that either. Because we don't know that from this scenario. So we just have to say that there is no valid conclusion. We can't draw anything from this.
Why is your end so large?
I don't know. It wouldn't be like that. Okay?
I will draw a vote.
Number 10. If you shop at Target, then you will use your Target Red Card. If you do not use your Target Red Card, then you will not get 5% off. Okay? You shop at Target is our
P.
You will use your Target Red Card is our
Q. Not
you do.
Q.
Oh, you guys are already on not Q.
And not R.
And then this can just be called R. We can. I know there's a not there, but we can say that's the original statement is there's a not there. So the not of not would be then you get 10%. Does that make sense?
Would you kind of wrong if
So-
somebody put not R?
No, because I don't make you actually label it. B to Q. This is just a tactic for help us. Not Q, then R. Do these exactly match up? No. So can we draw a conclusion? No. If they're not exactly the same, or if one's not exactly the same, one's not Q and the other's not Q, then it doesn't work, okay? Earlier with our a number and it, they're not word for word, but they're both Q. Here, well, they're not just both Q. One's Q, one's not Q. They're different. That make sense?
Can we just write NBDC for no valid conclusion? Because I don't want to write that out.
Sure. I mean, I understand it.
It's
Okay.
a lot of spelling.
On our 11, could we draw a conclusion?
Yes.
Yes.
We could, because it goes P to Q,
If
Q
it
to R,
snows,
okay?
then you will make up a list.
Yeah, okay. We're going to skip it, though.
What?
Okay, go to the next page.
Can we do more
Okay.
Please, I don't want to do this anymore.
Okay, we're gonna review these a little bit, and we're gonna work on combining them a little bit here, okay? So our law of detachment, here's how I remember which law is which, okay? Because you're gonna be asked to know which law is which. Here's how I remember. Law of detachment, what does it mean to detach something?
You take it apart.
You take it apart, you have a part of it. Law of detachment, if P then Q, then just P. Let's write that down, let's forget. Do we have only a part of our conditional?
Yes.
So that was detached. So our conclusion is the other part. So we detached it. For our detachment, we detached it. For our syllogism, do you detach anything? No. Okay? Let's write that down, let's forget. So I remember law of detachment is where we detach the conditional statement. And then I remember law of syllogism is our other one. Okay? So if you remember one, you know what the other one is because it's the other option. Okay? If you know what left is, then you know what right is because it's the opposite of left. Vice versa. Okay? It's true, you can know that. Okay. So we're going to determine whether from the two givens, if the conclusion follows this law of detachment or syllogism or neither. This law of detachment, we just write detachment. Syllogism. Neither, you write invalid. We say it's an invalid conclusion. Okay? So if I drive over the speed limit, then I will get a ticket. I drove over the speed limit. Drive over the speed limit is P. I will get a ticket is Q. We are also given what? P. I drive over the speed limit. I drove over the speed limit. That looks like P to me. Okay? And then our conclusion is I get a ticket. Our conclusion was Q. So that is law of detachment. We detach the P and the Q. We have P and we have Q. So this is our law of detachment. Okay?
Law of dead.
Loved it. Okay, question. Okay. Okay. 2. If Amanda goes to the restaurant, then she'll order a hamburger. If she orders a hamburger, she'll get fries. Okay? So let's first break apart what happens. Amanda goes to the restaurant. What is that?
P.
P. I think a good tactic is always to break apart our givens. She will get a hamburger.
Q.
She orders a hamburger.
Q.
That's Q again, right? That's the same thing. And then she'll get fries. That's a new one. That's R. So we have P to Q, Q to R. Now let's look what happens. Amanda goes to the restaurant. Have we seen that before?
Yeah.
That's P. She will get fries. That's R. So we went P to Q, then we went Q to R, and now we went, that's a really bad R. Then we went P to R. Does that follow from one of our laws?
That's not an R, that's a P.
Okay, we'll pretend it's an R.
What?
This is the law of syllogism.
That's a really big word. Okay.
I think we should.
Honestly, probably just could have just written a line through the P. And it would have been right.
Questions? Okay, let's go to the next one. Oh, if it snows, then I will wear my snow boots. If it snows, then I won't go to school that day. Okay? It snows. P. I will wear my snow boots. It snows. I won't go to school that day.
R.
We should already have an idea of what? We should already have an idea. We can't draw anything from it. We can double check. I don't go to school.
R.
Okay, that's R. I wear my snow boots. Q. That's, none of this is a thing. This is invalid.
Invalid.
It's an invalid conclusion.
Wait, are we done now?
Okay?
But like, we've drawn all three conclusions.
Okay. We're going to skip 4 and 5. We're going to skip 6, 7, and 8. We're going to go on to 9.
Oh my goodness, right here, I all of those.
Okay. Good work. Okay. Use the law of syllogism to write 3 conditional statements that can be formed from the following true statements. This is a little tricky, but we'll go through this. If a quadrilateral is a square, then it has 4 right angles. We're going to break this apart. A quadrilateral is a square. What can we call that? It has 4 right angles. What can we call that? Q, okay? Next conditional statement. If a quadrilateral is a rhombus, then its opposite sides are parallel. A quadrilateral is a rhombus. R, that's new. We haven't seen it yet.
It's the whole thing.
Its opposite sides are parallel. Is that also new?
Yes.
Okay. What letter comes after R? Okay. Moving on to the next one. C. A quadrilateral has 4 right angles. Is that new or old?
Old.
That's old. That's our Q from up here. It is a rectangle. Is that new or old? New. What comes after S? Next line. Letter D. A quadrilateral is a rectangle. Is that new or old? Old. Which one is that? T. We just call a rectangle T. Its opposite sides are congruent. Is that new or old?
U.
New. What letter follows T?
U.
Opposite sides of quadrilateral are parallel.
S.
Okay, that is S. Very good. It's a little bit different than earlier, but that is S. Okay? It is a parallelogram. Okay? That is going to be V. That's a new one. Okay, so we have a lot of different things going on here. Okay, so I'm going to write out here we have, I'm going to write on the left side. P then Q, U R. Here we have R then S. Here we have if Q then T. Here we have if T then U. And here we have if S then V. So we're asking, what we're asking once we break all those down, okay? Can we use our law of syllogism to combine 2 of these into a new answer?
I see one.
Okay, which one do you see, Justin?
I see A and C. Combined
Okay. A and C, because we go P then Q, Q then T. So we could go P to T, okay? Because we go P to Q, Q to T, T to U. So we could go triple and go all the way from P to U, okay? Is there another one that you guys see that we could do?
Yeah. R to.
We could go R to V, R to S, S to V. We could go R to V.
Wait, I don't know.
Okay, so does this part in the orange make sense?
Yeah, that
Okay.
part doesn't. I don't like.
These? Okay. So now we're using these and we're saying, can we combine any 2 of these or more to use the law of syllogism? So P to Q, Q to T. Could we go straight from P to T? To use our law of syllogism. To say, if a quadrilateral is a square, then it is a rectangle. Does that make sense? So let's actually write out that sentence. If a quadrilateral
Are we gonna have to write these out like on
is a square, then it is a rectangle. So we're only using the law of syllogism here. Okay. So on this one, we went P to U because we went P to Q, Q to T, and we took it one step further and went T to U. So we cut out our Q's, and we cut out our T's, and went straight from P to U. It's an extra layer. Ooh, get fancy. We can go an extra layer through the law of syllogism. Okay. And then our third one, we said R to S, S to V. You can cross out the S's and go straight from R to V. Does that make more sense at all? Even if you don't like it, does it make more sense? Are you just saying that? Okay. It sure just has the connotation that you're just saying that. So I just want to make sure. Okay.
When I'm doing this on like a worksheet, do I
Yes. You
have
write them out.
to know like PQRSTU?
It's handy because once we did this, was it a lot easier for us to see what's going on?
I mean like, can I switch all of those letters to A, B, C, D, E, F?
If you really want, but we commonly call it the first one P, the second one Q, and from there we just go off. It'd be really weird.
I don't know that order of
Well, it might be good practice. Okay, thanks for almost killing me. Trip people much?
Hey, if you ran into my foot, I thought you ran into you.
Oh, no.
Okay.
Are we done after this? Are we doing homework?
We are doing homework right now.
Woo!
We made a pretty good time on this, guys. After a quiz and going over homework today, it worked.
4 minutes to go. Let's
Yeah.
go. We're gonna do this whole worksheet in 4 minutes. I'm
That's
basically
what
good.
I'm already over this. Like,
It's not even hard. It's just gonna be a lot of.
I already hate geometry. Like,
I love geometry.
I like algebra 2 more than I like geometry.
You know, as a student, I did too.
I forgot it. You were talking. This is how much my patience is.